Choice 1. Given this equation of a line, which is in standard form, that means I know immediately my slope is equal to negative 3 over 4, and I know my y-intercept is equal to 3. So I'm going to start with my y-intercept. I'm going to go to the origin, and I'm going to go 1, 2, 3. My first point is here on the y-axis. Now I know that my slope is negative, so I'm going to go down 3, 1, 2, 3, and I'm going to go over 4, 1, 2, 3, 4. Here's my next point on my graph. I'm going to go down 3, and I'm going to go over 4. Here's another point on my graph. I can also go up 3, and I can go over 4. 1, 2, 3, 1, 2, 3, 4. Oops, that one doesn't want to go on its right place. And up 3 and over 4. So now I can go ahead and draw a line connecting my points. And of course they have to have an arrow, and that doesn't look anything like a line. I'm sorry, it's a little crooked. Okay, so that is my graph of the line. That's y equals negative 3/4 plus 3. The next part of my question asks me, is the point 3, 2 part of the solution? And my answer is no. 1, 2, 3, 2. The point of 3, 2 is all the way up here. That is not on my graph. It is not on the graph, so it is not part of the solution. There's another way I can think of this. I can also just take my equation and I can plug in my 3, where there is an x, and if my y comes out to be 2, then I know it is part. So I'm going to test that just because I think it's important to see whether we want to do it one way or the other. So let's look at now, let's go back to our equation. We have y is equal to negative 3/4 x, which I'm going to substitute for 3, plus 3. Well, negative 3/4 x gives me negative 9 over 4 plus 3. That's equal to a negative 2.25 plus 3. And that gives me a negative 0.75. Which does not equal what I originally had, what I have here, as part of my set. 2 does not equal 0.75, so this point is not part of my graph.